Good morning. Namaste. It gives me great pleasure to be in Bangalore this morning and to have the opportunity to share the vision and the technology of National Instruments with such a distinguished group of scientists and engineers. I may not be quite the accomplished speaker that Satish introduced me as, but I'll do my best to share with you what it is we try to do at NI and how we're going about changing the future. I'm going to give you a brief tour, a brief history of National Instruments over the last 40 years. And then I'm going to focus most of my time looking forward at what you, the scientists and engineers of India, and NI will do for the world together through system design. Now, when National Instruments was founded back in 1976, it was founded by 3 researchers at the Advanced Research Laboratory at the University of Texas in Austin. They each took a little bit of funding from their teacher retirement fund, started a business in a garage, worked on it for several years before they went full-time, and built it up as a real Silicon Valley type success story. And I was amazed in my trip in Bangalore in the last few days to see a number of startup companies that feel very similar to NI at the beginning. Accomplished advanced researchers looking for a way to add more value, starting a business, leveraging our system design tools to get a product to market very quickly. And at NI, our mission and our vision is very straightforward. We equip scientists and engineers to accelerate innovation, discovery, and productivity. That's fundamentally what we do. We're about the profession, about looking at the challenges that face the profession, from education, from early stage education, from getting kids excited about the notion of engineering, all the way through university, into all sorts of industrial applications to the most advanced scientific and commercial projects in the world. From projects like the Large Hadron Collider that depends on our core LabVIEW Rio architecture and our compact Rio and PXI hardware to control the particle beam, to SpaceX, which has managed to outcompete the US government in the delivery of space launch and space vehicles, leveraging commercial off-the-shelf technology and fully embracing the notion of system design as a way to accelerate productivity, innovation, and discovery. Now, a quick history lesson. NI started in '76, and we had one product, and it was a GPIB board. How many of you guys have ever heard or used NI 48? Okay, so some people in the audience might remember this product. We support it still today. The foundation of our business was built on connecting instruments that came from the instrument vendors with computers that came from the computer vendors. And we provided that essential link to enable innovative engineers who were embracing the emerging possibility of controlling instruments with computers to be more efficient and to be more effective. We provided them with a higher level of abstraction, delivering instrument drivers, so that the job of connecting instruments to computers to generate the innovation that was possible became a lot easier and more accessible to more engineers and scientists around the world. Now, that proved to be a very lucky or smart starting point. Because what happened over the course of the next 10 years is that the PC infrastructure and ecosystem exploded, and the capability of what was possible with a personal computer increased exponentially. And that opened new opportunities and new possibilities for NI. The next core stage in our evolution was the era of virtual instrumentation. And that was ushered in. The inspiration for our core software product, LabVIEW, was actually the spreadsheet, Lotus 123, that came out in 1983. The company took a set of its core developers and went off-site in a skunkworks project to generate and create the engineering equivalent of the spreadsheet, to create a productivity tool that was going to fundamentally change the paradigm of using computing in measurement and control applications, to make it far more accessible, far more productive to those who didn't want to labor through text-based programming. LabVIEW came out in 1986. It came out first on a Macintosh. It came out on a Macintosh because that was the only platform that could support that graphical paradigm. And then it ported to Windows in 1991 and has had tremendous success over its almost 30-year life. Now, LabVIEW has been a tremendous fountain of innovation for many companies. I've met half a dozen companies in India just this week whose core business is built on the capability of LabVIEW. Without LabVIEW, they would not be able to compete on a global stage. And we've taken that core technology and idea, and we have iterated and innovated relentlessly since, bringing it to real-time systems and then innovating to bring the FPGA component to enable LabVIEW to become a complete system design tool to deliver very, very sophisticated applications around the world. Now, we also entered the measurement business in that time frame, leveraging commercial analog to digital technology that became available, that's just obviously exploded with the advent of the communications industry. We were able to take the measurement science and put it on a plug-in board and encapsulate it into the PC to reduce the cost of measurement and control, to reduce the form factor, and to increase the performance. And we've iterated on those two core concepts over the course of the rest of the decades. If we look at our third decade, it became obvious that both on the hardware side and the software side, we needed to bring far more reliable, far more capable applications and technology to market. We massively expanded, if you look at our what we call our fever chart here, our frequency versus resolution chart, with frequency on the horizontal axis and resolution on the vertical axis. We massively expanded the capability of our technology to make measurement. In many cases now, exceeding the capability of traditional box instrumentation. And in many cases, we have the fastest, most precise instruments on the planet. On the deployment side, we brought out two core platforms that have enabled many, many applications that I saw in India this week. One being PXI, which essentially gives us a very high-performance, rugged system to be able to deploy our high-performance measurement systems. Gives tremendous throughput, leverages the latest commercial technology to provide very high performance, very high bandwidth, very low latency to enable very sophisticated applications. And our compact Rio system, leveraging at the heart of it our LabVIEW Rio architecture and that FPGA to enable the customization and operation of very, very sophisticated control systems at a very low cost and with a deployment option that fits the rugged environment that's necessary for many of these applications. This combination of technology from GPIB to virtual instrumentation on the way to our overall modular instrumentation and expanding into compact Rio, each case has been building on previous generations of technology, ensuring continuity for the intellectual property that's been developed by our customers in our tools over multiple generations of technology. Now, as we move into the fourth decade, this is going to be the decade of system design for National Instruments. Now, the original proposed name for LabVIEW was actually Graphical System. And that name got changed in the end because it seemed we were a company, a small company with not much brand at the time, and it seemed a little bit too far from our market position. But Graphical Measurement System was the original name that we proposed for it. And the intent behind LabVIEW has always been to be a system design tool. And in the last couple of years, we've really been able to bring that to fruition. And we're investing heavily in that system design capability. And the fundamental vision is really very simple. We're bringing to market a tool that brings the core engineering capability to be tuned by a domain expert very easily to fit their application need. So that same core technology can be reused in a medical device, can be reused in advanced aerospace applications, advanced automotive applications, can be used for control, condition monitoring, and the Internet of Things. And then we bring to that the deployment platforms so that you can prototype on PXI while you're trying to figure out your design. You may want to deploy it on compact DAC. You may want to deploy on compact Rio. You may want to deploy on one of our lower cost embedded platforms on single board Rio. But you have the freedom to develop that system design and then in a platform of choice and then deploy it at a cost-effective alternative for your high-volume applications. At the heart of that is our LabVIEW Rio architecture. And as you heard on the video earlier on, this is a very innovative, unique combination of the FPGA, the processor, and I/O. Very low latency, very high performance to allow that heterogeneous computing to build very complex, low-cost measurement and control systems. And the core objective of the LabVIEW Rio architecture is to allow you to do it very quickly, to prove out the idea at a very low cost so that you can innovate rapidly and be able to disrupt many industries that are controlled by large multinationals who have huge teams of engineers. We're trying to promote the idea of the garage entrepreneur, the small team that can be highly effective in approaching a problem from a different perspective, leveraging the latest commercial technologies through system design. And I see this every day. One of our most inspiring collaborations is with Lego, the toy company, through their Mindstorms application. If any of you have seen Lego Mindstorms, if you've seen children engage at an early age of 8, 9, 10 in building advanced autonomous robotic vehicles, it is really inspirational. These children are domain experts. They're domain experts at toys. And with this simple technology, they can build advanced robotics that would have taken an army of engineers 20, 30 years ago when I was a child. That opportunity didn't exist. That same core technology in LabVIEW scales all the way up to SpaceX. SpaceX is one of my favorite application examples because it shows where an innovative, free-thinking entrepreneur, very bright engineer, can leverage the latest commercial technologies, a very advanced system design tool, and he can outcompete NASA to deliver payloads to space. It's hard to believe the scale of their success. And LabVIEW is right at the heart of it. Now, the other thing I want to share before I go into looking at the future, because I do think the past is important as a predictor of the future. One of the core themes I want you to come away from NI is a consistent, relentless investment in innovation and a commitment to the customer for continuity. NI-48, our first GPIB core application for GPIB control, we continue to support that today almost 40 years later. As we brought out new software applications and we brought out new APIs and core new platforms, we have a relentless commitment for the forward compatibility of that software so that the intellectual property that you develop in our tools will be available for you to deploy in the future on future generations of technology, and that's our commitment to you. Now, NI has been successful. I want to thank everyone here who's a customer for your business. For those of you who aren't customers, I hope you will be someday. I'm fairly sure we can help you be successful in whatever your domain and whatever your venture is. And our success has come from a philosophy of relentless investment in innovation. You can see on the left our overall personnel in R&D. We have about 170 R&D people here in Bangalore, and we have a little over 2,000 people around the world. And the point I want to make when you look at this chart is our relentless commitment to this is really ignores some of the short-term dimensions that go on out there in the broader economy. In 2009, when the world almost came to a stop, we believe in the future. The financial crisis didn't change the need for engineering innovation, so we continue to recruit and invest. We continue to hire the best and brightest to drive forward our innovation. And as we've scaled up that innovation, we now see the results and benefit in our revenue. And then also today, this morning, you're going to see a large array of new products coming to market that will allow that innovation to continue and our customers to thrive and prosper. We also have a large commitment to India. NI's been in India for a little over 17 years. We've increased our staff in India by about 10x over the last decade. We have almost 300 people here in India. We've had tremendous success leveraging the unique engineering talent that's available here to us in Bangalore, and then also in sales and marketing and supporting our many, many customers around the world. If you're with the academic community, you'll know we have a very strong commitment to academia. We want more engineers and scientists to be inspired. We want more kids to be inspired to become engineers. That seems to be a little less of a problem in India today than it is in the developed world. In the developed world, they all want to be lawyers. Unfortunately, it's true. They all want to be lawyers. They don't want to be engineers. The reason they don't want to be engineers is because the way engineering is taught in schools is boring for many of them. Matrix math and calculus, it's tough to inspire young children to get really passionate about that when that's the vehicle of education, and we'll talk about that a bit more as we go forward. We have to change that paradigm, we have to change that framework. Now, as you know, innovation is coming to the world at a faster and faster rate. The incredible access to information and collaboration is creating an exponential explosion in innovation. And there are few countries in the world that are going to rely for their future on that innovation as much as India. Now, when we look at the emerging countries and we see what's necessary to bring that innovation to reality, in my opinion, there's three fundamental building blocks that need to be available, need to be highly efficient if we're going to be able to build that machine. The first one is access to technology. It is really difficult to compete on a global scale if the foundation of your innovation is already obsolete. There's an opportunity, leveraging the Internet of Things, to make that technology accessible to young scientists and engineers in India, drive the cost down, and that will create a fountain of innovation, and I'll talk about that in just a second. The second one is the education system. Generally around the world, my experience is that the current education system is not sufficient to bring to market scientists and engineers who are ready for the modern workplace. It's better in some countries, it's worse in other countries, and we'll talk a little bit about what you and I are doing together to try to improve that. And then affordability. There's lots of tremendous talent out there that just can't get access to the latest technology to get the opportunity to bring their idea to market, and we'll share a little bit of what NI is trying to do to address that issue as well. So let me first talk about the latest in technologies. We've all seen and witnessed a tremendous explosion and revolution in technology. Processors, the number of cores, the expectation that processors will soon, an individual processor take more computing power than a human brain. The expansion of the network effect of Metcalfe's law to machine communication, where we now have more connected devices than we have people on the planet, and that number is going to increase exponentially. Battery life. This is one we all probably get frustrated with every day. It's not advancing as quick as we'd like it to advance. But the reality is battery life has come a very long way. And with electric cars and the proliferation of mobile devices, there's an intense investment significantly improving the efficiency of our battery packs to be able to sustain much longer operation. Wireless communication, 90% of the world now has mobile connectivity. This is allowing the industrialization of the internet. The ability to place devices, measurement devices, sensors, connect them wirelessly very easily is opening up massive new opportunities to drive productivity and innovation. And then sensors. Mobile devices have been interesting. The explosion in sensor technology has been incredible over the course of the last 8, 9, 10 years. And today, pretty much any sensor you want is going to be available probably for less than $10. Certainly at the level where you're trying to build a prototype. So all these technologies individually creates a revolution in innovation. When you combine them together, they operate exponentially. And what we see with our customers every day is a massive transformation of the economy as we look forward over the next 10 and 20 years. And there's a tremendous opportunity for the engineering talent in India to play a first-class role in the next stage of that evolution. Now, there's a lot of discussion of the Internet of Things, and I'm going to talk about that for a little while today. But we focus on those 4 key building blocks, and we're going to focus on how the Internet of Things relates directly to the industrial world and how it directly affects to National Instruments and our customers. And when we look at the Internet of Things enabled by those 5 core technologies, there's really 2 views. Most of the conversation in the general marketplace in the media is about the consumer Internet of Things. It's about micro-efficiency. It's about consumer devices used by the individual to make their life more efficient. We're going to spend most of our time today talking about the left-hand side here, which is the industrial Internet of Things. The industrial Internet of Things needed a little bit more than the consumer. It needs secure communications. It needs reliability, low latency. So some of the core elements that have been necessary to really bring the industrial Internet of Things to life have come a little bit more slowly than that's driven the consumer side. Now, on the consumer side, we serve that space very well with products that are used for the design and test of the consumer products that are brought into market. And the value proposition there, when we look at it from the individual's point of view, as I said, is micro-efficiency. I can turn down the temperature in my thermostat at home because I'm going to be working late. I can find a parking spot because my phone knows where I am and it's connected to a cloud server that tells me where there's empty parking spaces. They're all good things that'll improve everyday life at the micro scale. My Fitbit will tell me whether I need to walk more or not. That's one I find particularly annoying, but useful. These are micro advantages. They then get deployed on a very wide scale, and they can have an impact on the economy. And they can have an impact on the life of the individual. On the left-hand side, the industrial Internet of Things, also known as Factory of the Future, Industry 4.0, it's really in its blossoming phase at this point. Some of those core technologies that were necessary, like secure communications, low latency, are just beginning to be deployed into the industrial setting, and we see a revolution going on among our customers. The first revolution that's going on is that senior management is now beginning to think that there's a business advantage from automation, monitoring, connectivity of their machines. That's a big mind shift from the past. In past years, they weren't aware of the business advantage. And more that business advantage is becoming very, very obvious, especially if you have large deployments of massive amounts of expensive machinery deployed around the world. And I'll talk about some applications that we're enabling with that. And the industrial Internet of Things spans at the macro scale. It's embedding monitoring technology in container traffic. It's automating the monitoring of large rotating machines. It's in a world of different applications where it can bring tremendous economic advantage by the automation of that data collection and processing and turning that information into business value. Another area is in the area of alternative energy or in rotating machines in general, and you'll see on stage today NI bringing to market a product called Insight CM Enterprise Edition. The core objective of National Instruments platform has been to abstract repeatable application areas and make them available to an engineer at a much higher level. And so we've seen tremendous feedback from some of our largest customers, customers like Duke Energy in the United States, the largest single utility in America, wanting to find ways to automate the monitoring of its rotating machinery to dramatically improve its uptime and extend the life of their equipment, in the process saving enormous amounts of money. Some of the largest telecom companies in the United States who have up to 10,000 facilities, operating chillers in 10,000 locations, spending billions of dollars of energy trying to find ways to optimize. The Internet of Things, the industrial Internet of Things with those core ingredients, including security, low latency, is now coming to market to enable those to be a reality. And then bandwidth. As I said earlier on, in the industrial setting, we're going to need a lot more bandwidth. It's got to have to be available. It's going to have low latency. And NI is working hard with the advanced researchers for 5G technology, many of the advanced research institutions in the world, to bring the next generation of cellular technology to market. And when that happens, which is not that far away, the ubiquity of the availability of bandwidth at low latency is going to completely change the face of the automation of the industrial world. Okay, so together we believe that engineers and our platform will be a key ingredient in creating the Internet of Things. Now, I want to spend some time talking about a topic that's passionate to my own personal interest, and that's the education challenges around enabling innovation. Now, you can pick any area you want, and you can see an enormous amount of innovation that's happened over the course of the last several hundred years in almost any area you want to pick. I'm picking a watch here because it's an easy one to look at. Get a watch now, it tells the time, it tells you how many steps you took, it does your email, so you'll be able to video your wife, all sorts of innovative things that are going to come along with telling the time. Then we can take a look at education, and engineering education. We've come a long way. We've come from white chalk on a blackboard, and we've advanced all the way to black markers on a whiteboard. We haven't fundamentally changed the process by which we teach engineering, and we need to understand in the future world, many more of these engineers are going to be involved in design at the system level. That higher level of thinking about how engineers are going to approach the problems of the day is the future. If they can't think of the application they're building across the domains that are involved in the system, electrical, mechanical, they're not going to be successful in the modern world. The necessity of integrating those elements, that's where the real innovation is coming. The core technologies, the building blocks are being provided by these very large companies. The opportunity to innovate is around the combination of those core elements, and that combination is heavily dependent on the ability to understand system-level design. Now, I read this article in the paper yesterday, and it surprised me a little bit to know that in the top 200 universities in the world, that there was not a university from India that was present. I was quite surprised to see that. And I talked through it with the team in India here, We look at the ability to bring forward innovation. We've got to change the approach. We've got to bring system design to the fore in engineering education, and we've got to start early. At NI, we believe in not learning by rote strictly. We believe in teaching kids to do engineering. It will inspire them, and it will enable them to be successful in the workplace of the future. The world is going to need system designers. The world has a massive lack of system designers today, and together we need to be able to find a way to address that. At NI, we've been working on this problem for quite a few years. Through our partnership with Lego Mindstorms Robotics, that is a system design platform to teach young kids to build autonomous robotic vehicles or self-controlled robotic vehicles. It's a sophisticated system design platform. It's also very accessible. It inspires them to be engineers, teaches them how to become system designers for the future. We've also expanded that platform with our own NI DAC and NI Rio, platforms that provide high functional density in the education environment or in the home for students for learning and doing homework, to allow them, when combined with the NI LabVIEW platform, to become system designers in elementary school, to perfect their skills in high school, and to polish their skills in university before they go into the workplace. These are the same core tools and technologies that get used in the workplace. At the heart of Lego Mindstorms is LabVIEW. At the heart of MyDAC and MyRio is LabVIEW. And those same platforms then take it to market both in our compact Rio platforms and obviously on into our data acquisition and production test applications in PXI. Now, we've worked extensively with some of the marquee organizations around the world, people like Lego, like First Robotics, the World Robotics Olympiad, to bring that core technology and make it accessible to tens and thousands and millions of young kids. We clearly need to do more in India to facilitate that as we go forward. Now, when we finish today, I'd love you to take the opportunity to walk out the door and take a right turn and go to the auditorium next, or 2 auditoriums down, and take a look at some of the kids from the universities in India leveraging MyRio as a design platform to build really, really cool measurement and control applications. We took over 2,000 submissions, and the finalists are here today to show off their innovation. And I was really blown away yesterday with the creativity they're able to bring to market in a short period of time. I want you to go for 2 reasons. I want you to go over because I want you to be inspired, which I think you will be when you see their creativity. And I want you to go because you will inspire them by your attention and your interest in what they've done. And you'll see the small little teams working for 4 or 5 weeks, building a product, designing it at the system level. And that is what is needed to solve the core challenges that we face in the world today and to create the opportunity and economic development that will drive India in the future. Working with our partners, we're exposing and training over 4 million future system designers around the world. We need to do better here in India to be able to deliver that experience and opportunity and help enable India to continue to grow in its competitiveness over the course of the next generations. Lastly, I'll talk about the issue of affordability. At NI, we've started a program called Planet NI, and we've helped hundreds of SMEs by giving them free access to software and training, reduced cost access to the initial set of hardware for control so that they can build their first prototype, so they can convince someone to fund them, so that they can prove out their idea easily at a low cost. The objective of this is to do 2 things. Our personal business objective is to build future customers, without a doubt. But the other objective is to enable these people to be able to prove out their idea and drive entrepreneurial innovation in countries where there isn't enough financial resources to make it accessible. I met several of the companies yesterday and the day before who've graduated out of that program to become successful commercial ventures. And if you have an idea and you'd like to participate in this program and you don't have access to the funds necessary, then please make sure to share that with the NI team and see if we can make this a reality for you. One of the examples that came out of this, I think, is very innovative. We had 4 biodesign fellows create a tool to address one of the core challenges of infant mortality, the failure to take the first breath. participants in the Planet NI program, they were able to gain access to the software and hardware necessary to prototype their design, to gain funding. They've used LabVIEW extensively in the design. They use our tools in the production test. And they're bringing to market and selling and supporting a very, very inexpensive infant resuscitation device that needs very little medical training to be operated. This is the kind of inspirational success that we want to see and generate. And this is the reason I want you to go next door and see those university kids and inspire them down this direction. This is not something that would have been possible for them to compete with traditional design tools, with expensive EDA tools, with all the core elements they would have had to build. They would not have been able to succeed and get up and going and get to market. So system design, leveraging a core standard platform that has that combination of the FPGA, the processor, and I/O, can allow you to revolutionize the market and get to market easy. And think SpaceX. It doesn't work just at the micro level. This works at the macro level, the very large-scale operations as well. Now, we look around the world. The U.S. National Academy of Engineers has really focused on setting a set of grand challenges that they're trying to inspire engineers and scientists to address, and they put them into 4 key categories: health, sustainability, security, and then the joy of life, which incorporates lots of different things. At NI, working with our customers, scientists, and engineers, we're working on all of these grand challenges, enabling many, many innovations to come to market that will be a very positive impact on the world. And there's one more I want to talk about that I saw here in India on my travels. This, again, I think is a pretty inspirational example, and addresses this first issue of health. This is a collaboration with the HTIC Institute to develop a cardiac measurement device for medical applications that can be used, again, by healthcare workers with limited to no training. Inside this device is our core Rio technology. LabVIEW is the system design tool. This is a product and technology that this group would not have been able to bring to market with any other technology and be competitive. And competitiveness is really, really important because the access to the technology at a very low cost of design and deployment is critical to enable it to become accessible to the patients who are relying on it for their future healthcare. Okay, so I'll close with that journey. I want to thank you for your time and attention. I want to thank you for your interest in engineering. I want to, again, encourage you to join the university students next door after you're done here. Encourage you to play your part in inspiring the next generation of engineers to become system designers. And I think together, engineers and NI platform will be a significant contributor to making the world a better place. Thank you very much.